Order, and welcome to our Innovation Showcase. The committee wants to understand how the UK supports innovators and what more can be done. So to inform our work, each week we select an innovator from before our main session to share their story. Daniel Zeichner suggested this week's innovator, so I'll ask Daniel to introduce them.
Thank you very much, Chair, and good morning, and thank you, Hendrik, for coming and presenting to us today. In some ways, I would say you're a classic Cambridge story in the sense that you did your PhD at the University of Cambridge. You were researching novel therapeutic approaches to treat blood cancers using next-generation sequencing and functional genomics, and then working with someone else, Professor Ulrich Kaiser, who was the inventor of a revolutionary modular soluble nanoarray technology for RNA detection. You then founded Cambridge Nucleomics to develop novel diagnostic tools addressing speed and cost constraints of the existing methods. And so from that spin out, and I think this will be of interest to everyone, developing a 1-hour sepsis test, replacing the 2-day current test, to help vulnerable patients with blood poisoning, and a pipeline of oncology tests based on that RNA detection platform technology. So I think we see many brilliant cases like this one. I'm delighted you've agreed to come and talk to us today about how you've done it and perhaps some of the challenges you've faced. Over to you.
Thank you, Daniel. Dear Chair and committee members, thank you for your interest in our work, and thank you for your determination to foster innovation and growth. I am Dr. Hendrik Runge, CEO of Cambridge Nucleomics, a spin-out from the University of Cambridge. We develop fast, actionable diagnostic tests that improve the selection of therapies and patient outcomes. Sepsis is when an infection becomes so severe that the pathogens enter your bloodstream, usually bacteria or fungi. It is an emergency and a global health crisis. It is responsible for 1 in 5 deaths worldwide, 11 million people per year, and 50,000 in the UK alone. We do have good drugs to treat patients, but we lack good tests to detect the disease early enough. With sepsis, survival is 80% in the first hour, but only 25% 12 hours later. Yet, current tests take days. This leaves doctors scrambling, essentially guessing in the absence of data how to best treat their patients based on gut feel. This is the problem we are solving. Our test will detect and identify the underlying pathogen in just 1 hour, fully automated and directly from blood. Crucially, this saves lives, but also reduces the hands-on time for overworked NHS staff to just 5 minutes per patient. But how big a problem is sepsis really? Let me tell you about Molly. 18-year-old Molly survived cancer, but chemotherapy weakened her immune system. She developed an infection that escalated into her bloodstream, and she developed sepsis. Molly survived cancer, but she died from cancer. Molly survived cancer, but she died from sepsis. This could have been prevented if she had received the right treatment early enough. 250,000 people develop sepsis in the UK annually. By targeting immunocompromised patients first, who are highly susceptible to fungal infections, which are very hard to detect with conventional methods, our tests will directly benefit 10,000s of British cancer patients and cancer survivors like Molly every year. Beyond the tragic loss of life, sepsis costs the NHS £2 billion every year and £11 billion to the wider UK economy. Many companies have tried to solve this, but they failed because they relied on legacy technologies like PCR and sequencing. Fundamental chemistry dictates that these tests will always take several hours, which is too slow. We are completely different. We invented a hybridization-based nanoarray that detects pathogen RNA without this need for slow chemical reactions. Instead, it binds to the target shape using nanotechnology. This enables us to run the detection in mere minutes and sub 1 hour for the entire test, including the automated sample processing. The technology enabling this radically novel approach took us 12 years to develop. Finding pathogen RNA in blood is a needle in a haystack problem. This is a problem where Human material outweighs the pathogen material about 1 billion to 1, so it's a huge amount. We essentially burn the hay and search the ashes with a strong, highly specific molecular magnet. This magnet is able to distinguish 50 different types of needles. That's an analogy, obviously. The world-leading science was developed right here in the UK at the University of Cambridge Cavendish Laboratory by my co-founder, Professor Ulrich Kaiser, as you mentioned. And it is protected by 2 patents. It is so revolutionary that industry veterans like former CEO of Solexa, the UK's most innovative next-generation sequencing company, now Illumina, got involved. It was Cambridge's world-leading ecosystem and legacy of innovation that made this possible. But translating this science into global impact is where some of the issues occur, and we accounted some hurdles. While Cambridge and London is arguably the best ecosystem in Europe for biotech startups, domestic funding and risk appetite are dwarfed compared to the US. Bureaucracy and visa restrictions delay progress in an industry where time is money and money is life. We are in a global war for capital and a global war for the brightest mind, and we must ensure that the UK remains attractive and remains competitive. For example, while safety and ethics are non-negotiable, we have to reduce the administrative overhead. When it takes 8 weeks of paperwork just to test 10 milliliters of volunteer blood, our international competitors move faster and beat us to the punch. Similarly, bureaucratic friction around the EIS scheme, while brilliantly intentioned, can severely delay funding or disincentivize overseas investors. We need regulations suited for real-world agility. I do not want our tax money to be wasted. I pay taxes too, but we have to ensure it reaches our most innovative companies. But let me end on a positive note. Despite these challenges, we have built a successful startup, raised £700,000 in funding, and are rapidly approaching technology milestones for a major funding round. We will be raising more over summer. We employ 5 scientists, all with PhDs, and are already generating export revenue. The wide applicability of our technology platform enables us to generate an entire pipeline of diagnostic tests. With our next targets, antimicrobial resistance, which I'm sure you're aware is a huge problem, and oncology testing for personalized therapies, our next frontier. Our goal is to provide actionable diagnostic insights that improve survival by combining world-leading precision and speed. We are driving UK economic growth, and with your support in streamlining the innovation pathway, we will build a sovereign British industry that saves thousands of lives. Thank you for helping us thrive. You can find more information and contact details on our website, cambridge-nucleomics.com. Do reach out. Supporting life science innovation means saving lives. Thank you.
Well, thank you very much, Dr. Runge. I speak for the entire committee in saying how impressive it is to hear about your technology and your innovation. How concerning to hear about the extent of the impact of sepsis in the UK and worldwide, and the points you made with regard to bureaucracy and incentives for investment are areas that the committee is very interested in, and we will be taking up. But thank you very much for your presentation. It's been really illuminating and inspiring. Thank you.
Thank you.
Order.